All right, guys. Today we're going to cover something else. Now, I need to explain to you when this will be affecting you. We're going to cover how to name acids, not only how to name them, but how to write their formula. So I want to go over a few things about what acids are, what they mean, and things of that nature. So if you'll get this sheet, I'm going to go over how to name. I'm also going to give you a new flow chart that does a better job with naming acids, and so you can kind of see how to do that as well. This will not be tested on your quiz tomorrow. It may be a bonus point, okay? But it will be on the test on Wednesday, okay? So it won't be tested tomorrow as far as affecting your grade. Maybe a bonus point or two. But again, so I do want to teach you this because you are going to have to know these. So the first thing I want to talk about is what are acids? When you think of acids, what do you think about? Yeah, stuff that burns through tables. But the fact is that's not necessarily true. Some acids, yes, they'll eat through anything, but the majority of them don't. Okay, so the way we label them, and again, and this is just kind of for knowledge base, is that we have two types of acids. We have strong acids and we have weak acids. Okay? No, this is just common knowledge. I just want you to kind of listen it and kind of go with it with me. Here's the good thing. There are only 6 strong acids. So what does that leave everything else to be? Weak. You could name acids all day long and still not name them all. So the point is that there are only 6 that are considered strong. I'm not going to go into the definition of why it's strong and why it's weak. It does not mean how bad does it hurt you. That's not the terminology that we're going to use. Now, can a strong acid hurt you? Absolutely. But it's not in terms of, well, that burns my skin, so that's strong. No, that's not has anything to do with that at all. So these 6 strong acids. This one. This one. That one. I do want you to write these 6 at the bottom of that page. Write those 6 acids. The ones with the handwritten words on them. Not the text box page, the other page. Yep. Yeah, the AP Chemistry page. The 6 strong acids. Now, do me a favor. Try not to write them like I wrote them. If you do, give some space because we're going to name these, okay? So give some space. We are going to name them. So either write them all down in a row, or if you write them 3 by 3, give some space in between. That's one of them. Which one? Very good. What did you say it was? Hydrochloric acid. So if you want to write that one. So it's hydrochloric is HCl. Maybe you recognize that one, maybe you didn't. But we're going to talk about how to know to name it hydrochloric acid. And there's a specific way we name it. So we have 6 strong and hundreds and hundreds and hundreds of weak acids. So when you think of acids, you think of bad things that can hurt you. Yes. Okay. However, anybody eat an orange today? Okay. What's in orange? Citric acid. So anytime you eat a fruit, there's acid in it. Anybody drink a Coke this morning or anything like that? There's all kind of acids in Coke. Okay, Mountain Dew. There's acids in any soda drink at all. So the point is, just because when you think of acid doesn't mean it necessarily hurts. Vinegar is an acid. Okay, so don't automatically assume, ooh, that's bad stuff. There are some that are dangerous. Yes, I get it. That if you pour it, it will burn you. Okay. Any of these 6. Okay, there are some other ones that weak acids can potentially burn you as well. They'll eat, yeah. And a burn is a very moving word, if you will. Burn, eat, devour, if you will, whatever. What makes them an acid? That's a great question. Hold that. I'm fixing to add one more point, and then I'll answer your question. Okay. Of these 6, there is a strongest one. And this one right here is the strongest. Okay, that is the strongest of all acids. That acid is so strong, it is illegal to have in a chemistry lab unless granted approval by the U.S. government. Okay, it is extremely strong. It is so strong that even glass can't contain it. Oil.
Are you serious?
It is placed in a batch of oil that keeps it protected from anything around it, because it will eat through glass, but not oil. Okay, why is that the case? So that is the strongest acid, to my knowledge, that we talk about. Even in AP, it's our strongest acid. I don't know if it's a stronger one out there. Okay, so what makes an acid an acid? Well, first of all, what do you notice all of these have in common? They all start with H. There's one other little commonality, and you don't have to write this, but I want to show it to you. They all have this behind them. And can y'all see what that is? AQ. AQ. So I know what you're thinking. What in the world does that mean? So that's not what I want to do. I want to do this. I want to do this. So AQ is its state of matter. What is S for state of matter? L is? G is? This is the new one. Some of you probably dealt with that this morning. AQ stands for aqueous. I can never spell this word. Did you say surprising, Keely? I heard you. Aqueous. Does anyone in here wear contacts? Okay, every night, what should you put your contacts in? The solution. Eye contact solution is an aqueous solution. So what do you think has to be present? A liquidy, watery solution. So all acids are mixed with H2O. They start out as a solid. You mix it with water, stir it up, and it turns into an acid. Okay? Now, yeah, you can get all these in solid form. So, but it won't do anything effective until you mix it with water. So water is kind of like an activator, if you will. So again, the powder form won't hurt you. I mean, you can do anything with it. You can have a acid fight with it if you want to. It's not going to mess you up. Unless you put it in your mouth or your eyes, then you're in big trouble. Because why? There's water there. But just the powder form won't hurt you unless you mix it with water. So what makes it... yeah. So let's not have an acid fight with powder. Yeah, let's not do that. So what makes it an acid? Well, we've already established that they all start out with H's. Let's just do this. This is the definition of an acid. I do want you to write that down. So an acid is an H plus donor. So what does the donor mean? They give it away. So every single one of these are going to do what with their H's? Give them away. Okay. So when I put it into something, it's going to turn into something else. Okay. So it's going to get so that is the basic definition of an acid. All right. So now let's go and practice in naming these things. So again, that's the basic explanation of what an acid is. And that's what we're going to do now. Like the 6 you wrote down? Yes, that's what we're going to do as a group. So I've come up with this little phrase, and it has helped some people, and they've really grasped onto it, and it makes sense to them. And it's this little part right here. And it's O, no hydro. Spencer, you said one a second ago. What did you say it was? Hydrochloric acid. So hydrochloric acid. Is there an O in this formula? No. Well, what does this say? If there is an O, there is no hydro. However, there is not an O, so what do you have to have? Water. Not water. You have to have hydro in the name. You with me? It has to have hydro in the name. So, if the formula has an O, then there will not be hydro in the name. Everybody okay with that? Okay. If the name has hydro, then there will be no O in the formula. Okay, so let's look at how to do this. So I want to start with F. Let's start with F. Does it have an O in the formula? Yes. So will there be hydro? No. Again, O, no hydro. So how do we deal with this? What we do is we talk about the polyatomic. What polyatomic is SO4? Sulfate. All right. What does it say? 8 turns into ic. So this is not sulfate acid. Okay, it's sulfuric acid. Sulfuric acid. Okay, so what does the H have anything to do? The H is simply an identifier. What does it allow you to do? It allows you to say that is an acid.
So it'll never be part of the name.
Nope. It'll never be part of the name. So what I'm going to do is I'm going to give you this flow chart, and let's see if we can do it with the flow chart. No, this is just for you to have. Okay, so look in the very top left-hand corner where the arrows begin. So the first question is, does the formula begin with an H? So let's look at letter G. Let's look at letter G. Does the formula begin with an H? Yes. So what way are we going to go? We're going to go to the right. Are the two atoms both the same? No. What are the two atoms? H and S. So we're going to go down or to the right? To the right. It is an acid. So there's a fact. Does the acid contain a polyatomic ion? No, it's just what? It's just S, the element. So what way are we going to go? All the way to where?
Write the prefix.
Okay, so go to the bottom. Write the prefix hydro. And again, this is where that little thing comes into play that I said. Does this have an O in the formula?
No.
So what does it need in the name? Hydro, very good. So it's hydro. Hydro something. All right, so write the prefix hydro, then the name of the second element with the ic ending. So it's hydro sulfuric. And then add the word acid. I'm not going to be like blatantly like rude about that. I get that you're trying to name an acid, and if it has hydro, I know, but I would like for you to write the word acid. All right, now I want to change letter H. No, I don't. I do not want to change letter H. No, I do want to change it. Sorry. Change it to H2SO3. And there's a reason why. H2SO3, not SO2. Okay? Shh. So back to the flow chart. Does the formula begin with H? Yes. Are all the atoms the same? No. So it's an acid. Does this one have a polyatomic ion? Yes. All right. This time, does it end in ate or ite? Very good. This is sulfite. So follow that arrow down. The polyatomic replacing ite with what? Us. So look right here. I already have it written. Ite turns into us. So the first one was sulfuric. So what is the next one? Sulfurous. Very good.
And that's only because it had more oxygen.
Well, it went from sulfate to sulfuric. And so the name changes. Okay. Ate is ic, ite is us. Okay, sulfurous. All right, so let's do I. HBr. And this is actually one of your 6 strong ones, so we can name this one as we go as well. All right, does it begin with H? Yes. Are they the same? No. It is an acid. All right. Does this acid contain a polyatomic? No. It's just Br, right? So the no goes all the way to that bottom box. Write the prefix what? How could you have looked at that formula and known? Very good. O, no hydro. Well, there is a no. There's not an O, so we need the hydro to take care of it. All right. So hydro. Then the name of the second element with ic as the ending. What is Br? Bromine, so it turns to bromic. Very good. So hydrobromic acid. Hydrobromic. Yes, ma'am.
So when it's asking does the acid contain a polyatomic, it's just basically saying if it has an O or not? Kind of?
Yes, essentially. That's a good point. What she just said is if it's asking if it has a polyatomic, well, all polyatomics have what in them? Oxygens. There's one, let's see, ammonium, which that will never be one. Cyanide. Is that the only one that I can think of? I think cyanide's the only polyatomic without an O. Well, it's a positive, and the H is a positive. It's not one. This is just for you to use. Cyanide. So, but there is such thing as cyanic acid. Okay. But I won't give you that one. All right. So let's go to the strong ones. So let's do the single one that we haven't done yet, and that's HI. As soon as you see this, is there an oxygen? So what do you need to put? Hydro. So you already know that. All right. Since it's hydro and it's not a polyatomic, will the ate and ite thing matter? No. So instead of it being "ide," it is now what? "ic." So right here, non-oxy acids. Look at the very bottom. What does non-oxy mean? No oxygens. So "ide" turns into "ic." So this is hydro, and this is the fun one. I like this here. See if you can see. So it's iodine. Then it turns into io what? Died. So it's iode ic. So it's hydroiodic. So hydroiodic acid. Hydroiodic acid. No. I kind of like that. I like that a little bit better. Yeah, let's do that, guys. And again, I'm always up for things that help you. This isn't for me. I know this stuff. This is to help you. So whatever I can do to make this better. So do that. So change this to no O equals hydro. I like that much better. Very good. Thank you, you too. Kaylin, very good. Spencer, you edited. Okay, I didn't hear anybody. I just heard those two. All right. So no O equals hydro. Whatever works for you. Here's the scary part, is that you're starting to think like me. Keely, yes, it happens. It does. I know. But the thing is you're learning. That's the good part. All right, so the other one was, let's see, we had HClO4. Now, you have to think through this one. Is there an O in this one? So will there be a hydro? No. So what polyatomic is that? That's perchlorate. All right, so we can't drop the prefix. So 8, perchlorate turns into ic, so it's what? Perchloric. This is the strongest, yes. This is one of the strong ones. HClO4. I honestly have no idea. I really don't know. I just know that we are not allowed to have it. We can't even buy it. Good luck. All right, and the last one is this one. Yeah. H2SO4. Is there an O? So O, no hydro. Okay. Have I done this one? Oh, I'm sorry. We did. We did an F. That's right. We did do an F. Okay. So HNO3. That's the one we need. HNO3. So there is an O. so we don't need a hydro. What polyatomic is that? That's nitrate. So what does 8 turn into? Nitric acid. Nitric acid. All right. So this is what I want you to do. The text box sheet, the back page, has 8 acids, and I want you to take the formula and write the name. See if you can do that. Yes. Okay, so let's do the 8 that you were supposed to name. So H2SO4. Now I know we've already done this one, but let's look at it. There is an O, so will there be a hydro? No. What is SO4? Sulfate, and 8 turns to ic, so it's sulfuric. I'm just going to write sulfuric. You know it's an acid. Okay. Now H2CO3. There is an O, so there's not a hydro. What is CO3? Carbonate. 8 turns to ic. So what is that? Carbonic. Very good. Okay. HMNO4. There is an O, so there's no need for hydro. But what is MnO4?
Permanganate.
Permanganate. 8 goes to ic, so this is a weird one. Permanganic. Okay. HNO2. Be very careful here. NO2. What is it? Nitrite. Ite goes to us. So it's what? Nitrous. Okay. I am doing acids. Yep. Nitrous. Okay. Now we've already done this one. ClO4 is not chlorate. It is perchlorate. So 8 goes to ic. So it's perchloric. Again, we've already done that one. No. Okay. All right. H3PO3. Be very careful here. H3PO3. PO3 is phosphite. So ite goes to us. So it's phosphorus. Okay. Phosphorus. Next. HI. We've already done this one. What do you notice about HI and HF? There's no O. No O equals hydro. So we got to get hydro in here. Now we've already done HI, and that was the weird one. Hydroiodic. Okay. But fluorine, we know the ide, IDE, which is fluoride. Ide goes to ic, so it's hydrofluoric. Now, hydrofluoric is a really dangerous one. Now, it's not strong, but it is dangerous. Same difference. Again, strong. Because you're going to keep asking, how's it strong but dangerous? Or how's it not strong but dangerous? What did I tell you that the basic definition of an acid was?
H plus
Donor. Donor means to. So if the HF gives it up, what has to happen to that couple? They've got to break apart. What makes it strong is that 100% of those break apart in a solution. So if I have 100 HFs, how many of them will break up? All 100. What makes it weak? Again, why? I don't know. I just know this is what it is. But weak is actually less than 5%. So if I have 100, less than 5 of them will separate. That's what makes it weak versus strong. And only 6 in the entire world are strong. Only 6. Okay, let's go back to the other sheet. And this time, let's take the formulas and let's go to, the name and go to the formulas. Now this time we have to kind of do a little bit of thinking. We have to kind of go backwards in terms of what's going on. we have to figure out charges based on suffixes. What is nitric? Okay. Well, ick turned into or came from what? 8. Ick came from 8. So nitric was really what? Nitrate. What is nitrate? NO what? 3 negative. You need to know this. Hydrogen, when it's not with a metal, and I'm specifically saying this for a reason, when it's not with a metal, is always 1 plus. How do I know that? What group is it in? It's in group 1, so it's 1 plus. So when I crisscross that, what do I get? HNO3. All right. Now let's be very careful on this next one. This one's kind of weird. Hypochlorous. Us came from which ending? Ite. But what about that hypo? You got to deal with it. What is hypochlorite? Very good. ClO negative. What is H always? Okay. So when you crisscross, you get HClO. Okay. Ick came from what? 8. This is kind of how I think about it. Sometimes, did you notice on sulfuric, I like to sometimes think ick is like Rick, so I ate with Rick. Yeah, I ate with Rick. So 8 and Rick go together. So, but it's not always going to be Rick as an ending. That's why we don't say that. Just like this example. So what is acetic? Where did it come from? Remember, ick, I ate with ick, so it's acetate. So what is acetate? Very good. C2H3O2 negative. So H plus. So really what's going to happen to those charges? They're going to go away. So it's just H, C2H3O2. And I know what you're thinking. Why did you write H twice? Why didn't you just say H4? Because what's wrong?
You can't take
Very good. You can't just pull that out of acetate because acetate is C2H3O2. You can't change it like that. You still have to have the H in front to make it an acid. Because if you get rid of the H, it's not an acid anymore. Okay? Yes, the H is always in front of an acid. Always. Carbonous. Okay? I ate with ick, but I ate with us. So this is carbonite. Is that right? Yeah. Carbonic. No. Carbonate is CO3. So what is carbonite? All right, but be very careful. What is carbonite's charge? 2 negative. So this one's a little different. So it's H plus CO2 2 negative. So when you crisscross, what happens?
H2CO2.
Because when you crisscross, the 1 goes there, the 2 goes there.
It's because it wasn't a parenthesis.
Yeah, because I didn't put it in parentheses. Does that help? All right, and the last one. As soon as you see hydro, there's no what? There's no O. Well, what is fluoric? F. So it's just H, F. All right, try the naming ones on that text box sheet again. Do those last 4. Really? Oh, we've already done. Yeah, just try the other ones then. Okay, so let's do the last 6 real quick. So the first one, sulfurous. All right, so I ate with Rick, but I ate with us. So this is sulfite. All right, so I know that H is always going to be H plus, but what is sulfite? SO3, 2 negative. So when you crisscross, you should get H2SO3. Everybody good with that? Hydrobromic. As soon as you see hydro, what should you not have? Oh, well, what is bromic? BR. Okay. Now, please, 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 I'm begging you, do not misconfuse hydro and hypo. They're very similar looking. Don't mess those up. Hypobromous, bromate is BrO3 negative. So what is hypobromite? Just BrO negative. Okay? So that's what it is. So it's H plus BrO negative. So what's going to happen to the charges? They're going to cancel. So it's just going to be HBRO. All right? Nitric. Ick. Go ahead.
Where did you get the, what's the difference between hypo and
Okay. If it was hydro, it'd just be HBr. But hypo, remember, is the prefix. Like hypochlorite.
But bro must make it.
Remember, because us is from ite. So this polyatomic is hypobromite. This is bromate. So it's just a difference. Well, hypo just tells you that it's this polyatomic.
Why is it there?
I won't give you one like that.
Why is there 3 after the hydrobromate?
Because it's hydro and there's no O. You hear me? Okay. Well, hydro it does, because if there's hydro, there's not an oxygen. Okay, nitric. Ick comes from 8, so that is nitrate. So it's just HNO3. And the reason why is because H is a positive, nitrate is a 1 negative. Phosphoric. Be very careful here. H3 ick comes from 8. What is phosphate? PO4, 3 negative. So when you crisscross here, you get H3PO4. H3PO4. And the last one, hydrosulfuric. Well, as soon as you see hydro, what does that mean? There's no O. But be very careful. Please be careful here. H is a plus. However, what group is sulfur in? 16. So what's its charge? 2 negative. So when you crisscross, what should you have gotten? H2S. Very good. That's the hardest one. Any questions there? Okay. Yesterday, you guys started with a dice game, right? All right, I want you to get that out. End of the video.